Hello, 7th graders. Here's a quick review for Chapter 3. On your test, you will need to be able to convert fractions and decimals, add, subtract, multiply, and divide decimals, add, subtract, multiply, and divide fractions and mixed numbers, and solve equations with fractions and decimals. First, to write a fraction, a decimal is a fraction in simplest form, you're going to say it, write it, simplify it. In other words, I'm going to say it properly. So since this is in the tenths place, I'm going to call this 4/10. So I say it 4/10. I write it as the fraction I hear, 4/10, and I simplify it by dividing the top and bottom by 2 to get 2/5. Again, say it, write it, simplify it. This says 1, the decimal point reads the word and. 1 and 5 is in the hundredths place, so 1 and 5 1/100ths. Simplify that, 1 and divide by 5, 1/20th. If I want to write a a fraction as a decimal, what I need to do is I need to take this top number divided by the bottom number. This is a division bar. It looks like a fraction right now. Fractions are division problems. So I could write the same thing out like this, 3 divided by 8. If I'm taking 3 and dividing it by 8, I'm asking how many 8s fit into 3, and none of them do. So I start with a 0. In order to keep going with my divide, multiply, subtract, and bring down of long division, I need to add a decimal point. When I have a decimal point in the problem, I'm going to bring it straight up in the answer. In the problem, I'm kind of ignoring it. Notice how 3 and 3.0, that's really saying the same thing. 3.00, same thing. 3.000, same thing. So I can add as many zeros as I want once I put a decimal point in there. So how many times does 8 fit into 30? That goes in there 3 times. 3 times 8 is 24. I multiplied, I subtract, I bring down a 0. How many times does 8 fit into 60? 7 times. 7 times 8 is 56. Subtract, bring down a 0. Now, I lucked out that I put 3 zeros, but I could have more zeros here. But that's all I need. 8 goes into 40. 5 times, exactly, because 5 times 8 is 40. And when I'm down to just zeros left, and I have a 0 down here, I can stop. There's my answer. If I have 3 and 4/5, that means I have 3 decimal point, and let's change this 4/5 into a decimal. Now I could make it an equivalent fraction over 10. That would be pretty easy, and call it 8/10. But let's pretend like I didn't notice that that could become a tenth. So what I'm going to do is I'm going to take my 4 divided by my 5. Again, I'm going to add a decimal point, add a 0. So I know 5 can't fit into 4. So I added my decimal point and my 0. Now, can 5 fit into 40? Sure, it can fit in there 8 times. 8 times 5 is 40. Subtract, I get 0. I don't need to keep going. I'm done. So this isn't my final answer. My final answer is to take my 3 and, so my 3 and 8/10. That shows 3 and 8/10. All right, if I am adding, subtracting, multiplying, or dividing with decimals, here are the rules. For adding and subtracting, I need to line up the decimal points. So I'm going to go ahead, line up these decimal points, or in other words, line up the place values. Now I can kind of ignore them. I'm just adding this like it's 6 and 159. So I'm just going to say 6 plus 9 is 15. 1 plus 5 is 6. And 1 plus nothing is 1. Put that decimal point right down where it would fit because I've lined them up. So it will be right there in that row. 2 and 5/100ths, same thing. I'm going to line up the ones place, line up the tenths place, and I'm going to add a 0 in that extra spot just so it's easier to see my problem here. So I'm going to take 5 minus 0, 0 minus 7. I can't do that. So I'm going to borrow from the 1, make it a 10. 10 minus 7 is 3. Ran into my decimal point, so I'll bring it down, and 1 minus 1 is 0. I like to put a 0 in front of a decimal point. It makes the decimal point more obvious. Now, those rules are very different from the next rules. The next rules are saying, don't worry about that decimal point at all. In fact, I'm going to multiply this pretending it's 156 times 4. Okay, I took out those decimal points. Now I'm multiplying just like I would if it was that big number. Okay, and I get 624. Well, 624 is not my answer. 624 is the correct digits, but now I'm going to count how many decimal places were in my problem. So really, that's what my problem looked like, even though I was ignoring the decimal points. And I had 1, 2, 3 decimal places. So I'm going to take those 3 decimal places. I'm going to start at the back where the decimal point used to be, and I'm going to move it forward 3. 1, 2, 3 decimal places. So my answer is 624 thousandths. Okay, the next one. I'm doing the exact same thing. I'm ignoring the decimal points at first, but when I take 3.09 divided by 0.6, I have a problem. I can't think in terms of 6. So in order to ignore the decimal point, I actually have to remove it from the divisor. It doesn't matter if I still have a decimal point inside this box, but I need it to be out of the divisor. So to do that, I'm going to multiply this by 10 or move the decimal point over 1. So if I move the decimal point over 1 or multiplied by 10, it moves here. So let's rewrite that. On the outside should be a 6. On the inside is 30.9. And we talked in class about why it works out to be the exact same answer if you do the same thing to the outside as you do to the inside. So now I can do this problem. 6 does not fit into 30, but 3, but it does fit into 30 5 times. 5 times 6 is 30. Subtract, I get 0. Now I'm not done because there's still a 9 here, and I need to still use the 9, but before I do, I'm going to bring the decimal point up when I get to it in the problem. Bring down the 9. How many 6's fit into 9? Just 1. 1 times 6 is 6. Subtract, I get 3. Remember, there can be as many zeros as we want here, so I'm going to add a 0, bring it down. 6 goes into 30 5 times, 5.15. If I'm adding or subtracting fractions, I again have the same rules as each other. I need a common denominator. So the first thing I'm going to do is I'm going to rewrite these fraction parts with common denominators. 5 and 3, they both multiply to be 15. So that's my common denominator. To get to 15, I multiplied 5 times 3. So I'm going to do the same thing to the 3, and I get 9/15 is equivalent to 3/5. Now this 2 here, I'm just going to keep it a 2. It doesn't change. But I did change my 3. I multiplied it times 5 to get 15. So I'm going to multiply the 1 times 5 to get 5. Now I can take my fraction parts and add them together. I get 14/15. And my whole number parts, there's nothing in the first one, and the 2, and I get 2 and 14/15. The next one, same thing, I want to have common denominators. I'm going to keep my whole numbers whole, and my common denominator is 8. This one I didn't need to do anything to, or you can think of it as multiplying times 1. 2 times 4 gave me 8, so I'll multiply this times 4. Now, when I want to subtract 4/8 from 3/8, I can't do that without borrowing from this whole number. So we're going to think about pizzas. And if I have a whole pizza and then I have 3/8 of another pizza, I could take this whole pizza and I could cut it into 8 pieces, right? And so I'm taking one of my whole numbers, in this case I only have 1, and I'm cutting it into however many pieces I see on the bottom. So I'm going to change this from 3/8 to 11/8 because I'm taking this whole number and I'm adding it into my fraction. I made it an improper fraction here. It won't always be making it mad or into an improper fraction. Sometimes you will just borrow 1 to make it 1 smaller, but you could make it into an improper fraction every time and it would still work. So I'm going to take 11 minus 4, which is 7, and keep the same denominator, 7/8. If I'm multiplying is actually way easier. I just take my top times my top and my bot times my bot, or my bottom times my bottom. So I'm going to make it mad first. I'm going to multiply and add to make this an improper fraction. And then I'm going to multiply across, top times top, bot times bot, and simplify when I'm done. 21 fits into 28 one time with 7 left over out of 21. Divide by 7, I get 1 and 1/3. And dividing fractions is easy as pie. Flip the second and multiply. In order to flip the second one, I need to have a top and a bottom. So first things first, I'm going to rewrite this division problem. I'm going to keep it division with an improper fraction. So I've got 3 5/3. Okay, dividing fractions is easy as pie. Flip the second and multiply. Top times top, bot times bot. Simplify when you're done. That's in simplest form. All right, if I need to solve an equation, I'm going to do the exact same steps that I did when I solved equations with whole numbers or integers. I'm going to try and isolate or get this m all by itself. To do that, I want to do the opposite of what I see. I see plus 1.2. So I'm going to subtract 1.2 from both sides. Oops, my pen touches there. That's why I moved that one over. So I've got m on the left-hand side, and on the right-hand side, I need to do this math problem. Remember that if we are adding or subtracting with decimals, we want to line up that decimal point. And I subtract, I have the decimal, I subtract again. There's my answer. The cool thing about these is you can plug them in and try it. 1.2 plus 2.2 does give me 3.4. All right, the next one, I noticed that the z is touching the 0.3, so that means I need to, right now it's being multiplied, so I need to divide by 0.3 in order to solve this problem. So z equals 4.2 divided by 0.3. Uh-oh. I'm going to move this decimal point so that I'm taking 42 divided by 3. Much easier. 3 goes into 44 one time. Bring down the 2. 3 goes into 12 4 times. So it's 14. I don't need to move any decimal points because I did the same thing on the outside as I did on the inside. These work the same when we have a fraction. So if you look at this one, if I want to solve for n, and right now n is touching the 1/3, I need to divide by 1/3 because right now it's being multiplied. Dividing fractions is easy as pie. Flip the second and multiply. So instead of writing it as divided by 1/3, I'm just going to go ahead and say I know that that's the same thing as multiplying by 3/1. Make sure that you have your whole number as a fraction. Top times top, negative 27. Bot times bot, 1. N is equal to negative 27. And the last one, I want to get k all by itself. Right now, I'm subtracting 4/5, so I want to do the opposite. I want to add 4/5. I need to get a common denominator, so 3/10 plus 4/5, a good denominator would be 10. I'm going to change that to a 10. To change 5 to a 10, I multiplied it times 2, so I'm going to multiply that 4 times 2 and get 8. Add the tops together, I get 11. Keep the same denominator, tenths. Now, I don't want to leave it 11/10. I want to change it to 1 and 1/10. All right, bring your questions tomorrow. I'll see you for the test.